All right, welcome back. This is now the problem solving segment for section 14.2 in our textbook McMurray. This is problem 14-4, where we're given a unique diene. This is a new diene, and we're told to react that diene with HBr and to predict the products. So remember, with diene systems, there are two products. There's the 1,2 product and the 1,4 product. Okay? So we need to look at our diene here and think about it. Now, this is arbitrary in terms of which end I start at, but there's 1, 2, 3, 4. And we have to decide, is our diene symmetric or unsymmetric? Okay? And if it is unsymmetric, then there can be two different kinds of 1,2 addition products and two different kinds of 1,4 addition products. And the worked example in your textbook goes through that. But for this problem, what I hope that you see is that there is a plane of symmetry, or a C2 axis in this molecule. And so the two ends of the diene are the same. So whether I do 1,2 addition here or 3,4 addition, which is really just 1,2 addition from the other end, remember it's arbitrary, which end is 1 and which end is 4, I only have one 1,2 addition and one 1,4 addition product. Well, sort of. We're going to ignore stereochemistry for now. So the first of these products, the 1,2 addition product, of course, the H adds to the less substituted carbon. According to Markovnikov's rule, we still follow that, and we get the bromine on that position. Now, don't forget, the hydrogen is still here. I'm just trying to emphasize the ones that we're adding. So this is the product of 1,2 addition plus the product of 1,4 addition. And I hope you can see that those two are different compounds. So here is the 1,4 product. So being able to do what we call predict products is a very important skill for organic chemistry. Now, when we say predict the products, we actually mean not only predict the products, but we mean two other ways of looking at this problem. So we were given this problem as starting material and reactant, or reagent, or a reactant, and here's our reagent. Our reagent was HBr. And what products would we expect to obtain? Now that is directly predict the products. And although I call all of this predict the products, what we also have to be able to do would be to look at the reaction, and if we didn't know what the starting material was, looking at the products and the reagents, can we predict the starting material? So every reaction you need to learn forwards, then you need to learn it backwards. You need to be able to look at products and predict the starting material, and then of course, if there's no reagent, one wants to be able to look at starting materials and products, and what is the reagent that I would need to make this organic transformation occur. So that's really three different ways of looking at this reaction from one predict the product term here. We're just going to call it predict the products, but on the exam, for instance, one might expect to predict the product, or given the product, predict the starting material, or given the starting material and the products, predict the reagents. And we need to be able to learn reactions from all three of those perspectives. Now, I always encourage students to make their own flashcards. I know you can buy these things online. The sets don't normally actually correspond exactly to what we're teaching. And the process of actually making your own note card is really important. So you really should make 3 of these flashcards. I say note cards because I just go to Walmart or CVS or someplace and I buy 3x5 or 4x6 note cards. And you should draw a starting material and a reagent and predict the products. I typically make a note down here of some page number from my textbook so I can go and review that. Okay? Then on the flip side of this, I would actually draw in the product. Okay? I will make a note, something about the scope. Okay, that might relate to my reagent here, or it might relate to a limitation of the starting material. Okay, and then I always make a note, do I need to know the mechanism of this reaction? And if I need to know it, I put a little question mark. Then you flip over on the back side of your card, and on the back side, you put in the actual product. Now, I don't know when you guys learned your multiplication tables, but for me, it was in 3rd grade. We couldn't afford to buy flashcards then, so my dad brought home some things that were not quite note cards from work, and we made flashcards for me to study my multiplication tables. The reactions are the multiplication tables of organic chemistry. And just like you have to just go and memorize those, our reactions are the things that we have to just memorize. And this is stuff that at first it seems like pure rote memorization, but as time goes by and you begin to learn to recognize acids and bases, electrophiles and nucleophiles, then you can begin to reason your way through reactions that you might have never seen before, or that you think you've never seen before. Okay? So, at first though, we've got to have some knowledge base, and these are our multiplication tables. You need to go and learn them. So here's a note card that was for predict the product. And then I'll give you just one brief illustration here. Another example might have been where we had the product and we had a reagent, but the starting material was in question. Okay? And so again, then on the flip side of this, you would put the answer. Never put the answer on the same side. Okay? Never put the answer on the same side. That's the biggest mistake that I see students make. They draw the answer in here, they look at it, and they go, oh, I got it. They don't got it. The card's got it. And so that's really important. Okay, so one final thing. We, from this diene, predicted the product of HBr. I'm going to leave as an exercise for you. Here's Br2. What does it mean? You predict the products now for this new exercise.